Hi guys, I am going to start on problem number 15, and I'm going to start by drawing the problem here. I have a car. Let's draw the slope going the other way. No, never mind, we'll do it this way. Alright, so I have a car. It's driving up the ramp at 31 meters per second. It runs out of gas at some point and then begins to roll back down. And the question is, how far, at some point up here, he's going to hit a velocity equal to 0 and start to roll back down again. What is that distance? How far? So always remember to write down what you're supposed to find so you don't solve for the wrong thing. So distance equals what at v equals 0. I'm going to write that down to remind me that's what I'm looking to find. Now this is interesting. I have this. If I were to rotate this perfectly vertically like this, it sounds like a free fall problem. You have something going straight up with initial velocity. It's going to go up and it's decreasing under the influence of gravity, right? And eventually reaches a velocity of 0 and then reverses direction and starts to come back down. So this is very much like one of our free fall problems, except instead of it being pointed directly up, it's pointed at an angle, only 8 degrees. But we're going to solve it in very much the same way with one small exception. Acceleration due to gravity won't be 9.8, it's only going to be a portion of 9.8 because we're only at an 8-degree angle instead of a 90-degree angle. So if I were to solve this like a perfect free fall problem and to draw the velocity time diagram, it would look like this. Starting with a velocity, actually because of the way I drew my coordinate axes, I actually have a negative velocity here, don't I? So let's draw my x up here, negative y. So I'm actually starting down here at a negative 31. It's simply negative because it's pointing in the opposite direction. And the magnitude is going to decrease. Magnitude is going to decrease approaching 0. Because I ran out of gas, it has nothing pushing it up the slope anymore. But I have acceleration due to gravity pulling it down the slope. So the magnitude is going to slowly decrease until I get to 0. And then it's going to reverse direction, start coming back down the ramp. Now when it comes back down the ramp, now I'm going in the positive direction, so velocity goes positive. Okay, so this is just like any other free fall problem we had. It's reversed here. But on all of these before, the acceleration was 9.8 meters per second. Now I'm not perfectly vertical, so I know that my acceleration will not be 9.8. It's going to be a fraction of 9.8. What fraction? Well, we have to go do that calculation to determine that. So let's look at that. So if here's my slope, here's my car. Acceleration due to gravity pulls directly down like this. Let's break G into its coordinate axes. One perpendicular to the ramp and one parallel to the ramp. So this is gx and this is gy. And this angle will be 8 degrees. So I don't really care about gy. The fraction of the gravity that's working perpendicular to the ramp isn't going to affect anything here. The only thing that's pulling the car back down the slope here is that component that is parallel to the slope. Gx is the only one I care about. So let's just solve for gx. Gx is opposite over here, so I know I'm going to have sine of theta equals opposite over hypotenuse, which I didn't label. That's g. Let's do some algebra to rearrange. What do I get? G x equals g sine of theta. Okay, let's plug in the numbers. G, of course, is 9.8. Sine of my angle, which is 8 degrees. Now let's double check my sines here. Okay. All right, so what should I get? 9.8 times sine of 8 degrees equals 1.36. So gx equals 1.36. So that's the acceleration that's parallel to the ramp. Now again, I can come up here now, and I now know my acceleration, so I can apply this to this slope. I now know that acceleration is 1.36. Again, let me just remind you, this was very similar to what we were doing for free fall. If I had a ball I was throwing straight up, it went up and came back down like this. The curve, velocity time curve, looked like this. I started with some positive velocity, decreasing to 0 and then reversing and becoming negative. And the slope of this was my acceleration, which is due to gravity, perpendicular, is 9.8 meters per second squared. Okay, so this is very similar, except I'm not perpendicular, I'm rotated from the perpendicular, and in this case I'm going up this way instead of going up this way. So I'm slightly rotated, but the method is exactly the same. So my acceleration, 1.36, is the slope of this curve. Now, what do I know here on the curve? I know the velocity, I know the acceleration, and that's supposed to be time. Did I really put x there? That should be time. This was a velocity time chart. So I know acceleration, and if I know acceleration and velocity, I can find delta t. But that's not what I was supposed to find. What was I supposed to find? Distance. So do I know an equation that relates acceleration, velocity, and distance? And yes, of course. I can come back to chapter 2, and under my formulas right here for an object with constant acceleration, here's my formula right here that relates velocities, acceleration, and distance. Distance is what I want to find. So let's go ahead and write that equation down. So I have v final squared equals v initial squared plus 2 times my, now notice in this case this is where it gets really important. That's where the subscript x becomes important if I'm dealing on a ramp here. So 2 times the acceleration, change in distance. Okay? And the acceleration here, the reason they have an x is they're basically saying the acceleration that's in the same direction as x. When we were dealing with free fall, the acceleration was vertical, but so was the change in distance. Now we're talking about a ramp, so I'm talking about the acceleration parallel to the ramp, which is in the same direction as the distance I'm traveling. Okay, so let's plug in what we know here. Our v final is going to be 0 because we're going from a negative value and approaching 0, and I want to know this point right here. So I have vi squared equals minus 2a delta x, and of course I'm solving for delta x. Okay, my velocity is negative, but of course it's going to be squared, so it won't matter. Minus 2 times my acceleration. Now my acceleration is moving in the positive direction according to the way I define my coordinate axes, so my acceleration here would be positive. So let's calculate. What do I have? 31 squared divided by 2 times, divided by 1.36. I have 353.3 meters. And of course it should be negative. So what does that tell me? That I am going to move 353 meters in the negative x direction up the slope before my velocity reaches 0 and I start to roll back down. So there's your answer. How many significant digits did they want? 2 significant digits, so I would round that to 350. Now they are asking how far will it coast, so they're asking for a distance, not a displacement. So in this case I should be able to just put in a positive number. I don't have to worry about negative. They're asking how far will it roll. They're not asking in what direction it will roll.